Hello and welcome to CI Stories. In today's episode of CI Story, we want to look a little bit at the propulsive concepts of different marine robotic assets, so of ROVs and AUVs, and how they are propelled, how many propellers they have, etc. So the way that the platform is propelled forward determines in which direction we can turn or move a vehicle or vessel. So the first few directions are typical for a normal surface ship that can obviously travel forward and backward with the normal thrusters. And then with the help of the rudder, it can also veer to one side and change its direction. With some special side thrusters, for example, also a ship can move to the side and move sideways. Uh, these are the same axes that are also available in most underwater assets. So, for example, an AUV can be propelled forward, usually not backwards, but in principle it's possible, and it can turn sideways. What it also can do is can going up and down, and it does that either by the direction of rudder panes, or it can use thrusters to introduce this vertical movement. So as you can see, there is only a certain degrees of freedom that a certain propeller configuration can operate. And if we now have a look at the more complex behavior of a modern robot, for example, here we start the video of the Saab Sabertooth, and there you can see different thrusters operating in a lot of different directions, maneuvering the vehicle in a stable way. And that is something that we engineers call 6 degrees of freedom. So this vehicle can actually position itself into any attitude, so any angle relative to the Earth, and then move forward, sideways, or rotate. Okay, so let's look again at the typical motion capabilities of a normal torpedo-shaped AUV. So that can obviously move forward, and then it can also turn sideways to the left and to the right. And using the rudder panes in the aft, it can also pitch down and pitch up to control its path. This type of vehicle cannot move sideways or vertically by itself. If we now, however, look at a 6 degree of freedom vehicle, like here our under ice ROV Beast, where you can see the thrusters are oriented in what we call vectored configuration, the vehicle can move freely in all directions. Obviously, it can also move forward, aft, but it can also move sideways and vertically. But then it can also move here, as you can see in the pitch direction, so moving up and down, and it can move in the yaw direction, so sideways, just as a normal vehicle can, or a normal AUV can do. But then the special thing about these vehicles is that they can also move in the roll direction. So the vehicle can actually turn on a side and then reach special observation targets. So you can, for example, then with the normally downward facing sensors, look at the side of a shipwreck, which was very important in the endurance expedition, but is also very important for the scientific use of this data. As you can see, the configuration of the thrusters on this vehicle determines how a vehicle can move, and there's different types of these vehicles. Of course, torpedo-shaped vehicles have the advantage that they glide easily through the water column, and they have very little resistance, so they're very efficient in traveling long distances. But if you want to have better vehicle control in all directions, then it's obviously better to have a vector thruster configuration and be able to maneuver the vehicle into whatever position you might want to position it into. With that, I hope that you have learned a little bit on ROV and AUV propulsion systems. And with that, I thank you a lot for watching again, and Have a nice day.